Ever wondered why your motor says 2 kilowatts, but the supply seems to work a lot harder? That's the power factor. And in the next 2 minutes, I'll show you exactly what that is, why it matters, and how to fix a bad one. So this is a perfect sine wave. I'm just going to draw it, and wow! This is a more realistic sine wave, where there is a slight delay measured by the angle between the two sine waves. This one will be around 0.6. I'm going to need to go back in conjunction with, oh no! AC systems have voltages and currents as sine waves. If they're perfectly in step, all power you draw does useful work. If current lags or leads, some power just sloshes back and forth. The power factor measures how much of what you draw is actually useful. The real power, P, comes from the reactive power, Q, and apparent power, S, form a right angled triangle. As seen by these equations here in my little box, reactive power does not do work. It just stores and returns energy in a magnetic or electric fields. Low PF means higher current for the same useful power. Higher current means hotter cables, bigger transformers, more voltage drop, and if you're a business, penalties or higher demand charges. For fixed, P is I, whatever that is, 1 over PF. Losses is whatever that is, I squared R. That looks like shit. Oh, thinking now. Inductive loads, motors, welders, and transformers make current lag voltage, lagging PF. Purely capacitive loads make current lead, leading PF. Most sites are inductive, so PF is typically lagging. Let's say, for example, a 240 volt load, 10 amps, at a PF of 0.6. The apparent, pretend that says apparent, power, I'm not going to write the whole thing, equals V times I, which is equal to 240 times the 10 amps. You get me? It's 2.4 kVA. Real power can be calculated from S times PF. We got our S before, so it's 2.4 times 0.6, and we get that from the P here. And that leaves us with 1.44 kilowatts. We can find the reactive power doing Q equals square root S2 minus P2, which would equal to 1.92 kVAR. You get me? I don't know why I'm doing that. If we correct PF to 0.95 with capacitance, for the same P equals 1.44, current becomes P divided by V times PF. Do that. 6.3 amps. And the current drops about 37%. So cable and transformers loses plunge. Box it. The fix is a capacitor bank at the board or across the motor to supply the reactive part locally. Due to my expertise and understanding in the field, you should now know how to bring your PF near 1, lower the I and lower the I2R losses, and capacitor bank for the inductive loads. Power factor is simply how efficient your AC supply is being used. PF equals PS equals cos angle. Keep it close to 1 with the right correction, and you'll get cooler gear, tighter voltage, and lower bills. What a shot.